The following video presentation will show the work that we have done for our project, Sharing Research through Replicable Data Science Environment. The project was mentored by Srikant Krishnamurthy. First, we'll show you what are the main contents of the video. First of all, we will talk about Research Hub and the motivation behind designing Research Hub. We will also give you an introduction to the client application. Next, we will discuss a little bit about Sandbox. Then, we will discuss in detail about the goals of the project and how we achieve those goals. They will be discussed in step 4, 5, 6 of the video. Finally, we will conclude with future work and conclusion. Research Hub is a result of growing interest among researchers and other stakeholders to create and share reproducible code. Next, we will show you an introduction to the Research Hub application. Welcome to Research Hub. Research Hub allows researchers to share their research with their peers using a front-end client-based application. The idea of Research Hub is to publish your research materials and code, and that can be done using the new project form. You could register a new project in the application using this form. Once a project is registered, the project would be listed in the home page of the website. We also provide basic functionalities like update and delete of projects. People could go and change the details about the project if they want to. Projects, if they're not required anymore, researchers could easily delete the project using the delete functionality of the application. Once a project has been created, it can be seen using the View Project button. The View Project is a dedicated project page which allows you to see the project abstract, the paper if it's associated with it, the project homepage if there's a website associated with it, and also allows people to run projects using Sandbox. We will explain this functionality later in the video in detail. Now we will briefly discuss about Sandbox. Sandbox was developed by our project mentors in previous version of this course. The idea of Sandbox stems from a very simple fact. Researchers who are publishing their own code use a lot of different libraries and packages. Interested parties like students or other researchers who try to replicate these codes often land into a lot of problems because they might miss out on different intricate details about the application. Sandbox provides containerized solutions to solve this problem. Researchers who are interested in making the code public could easily go and put the code on Sandbox platform. Once the code is on the Sandbox platform, researchers and interested parties could come and launch the code using Sandbox, different cloud instances on Sandbox. For example, people could use Amazon Web Service and Google Cloud Platform. We're also working on integrating Massachusetts Open Cloud. The most interesting thing about Sandbox is that people don't need to understand how and why these cloud services work. They just need to use this web interface and the rest is taken care by Sandbox. Once a project is launched, it could be executed using the task panel in Sandbox. People could just use the play button to launch the project inside Sandbox. Now we are going to show you an example of how a Python project, or more specifically a Jupyter notebook, is being run on Amazon Cloud Services and is executed inside the framework of Sandbox. We identified three main goals in this project. The first goal was to create an application called Research Hub. Research Hub is where researchers could go and publish their code and project-related materials. The second part of the goal was to create a pipeline between Research Hub and Sandbox. Finally, we also wanted to extend Sandbox services to allow Google Cloud and Massachusetts Open Cloud services. The research paper that we use in this demo is called Evaluation of Glyph Design for Improved Probabilistic Categorization Accuracy. We would like to thank all the authors for providing us an opportunity to use this paper. The demo code is also associated with the paper, and the code was written in Python 3. Now we will show you the application with the paper and the code. Using the code showed before, we created a Docker image, and this Docker image was then pushed to Docker Hub. For the sake of consistency, we will use this Docker image throughout our video presentation. Next, we are going to explain how a new user will create a project using Research Hub. The first step involves creating a new project on Research Hub. A new project could be created by filling up the new project form. Once all the information has been provided by the user would be then redirected to QSandbox. There is a special way of redirecting to QSandbox through Research Hub. The user has to click on this Publish on QSandbox checkbox to be redirected to QSandbox. Once the user clicks on this button, he or she is redirected to the QSandbox portal. On QSandbox, we have to provide information required to execute the application on the cloud. In the QSandbox registration, user has to provide the description about the file. Once the description is provided, people have to go and add the image URL, the Docker Hub image URL. Along with the Docker Hub image URL, we also need to justify what is the setting of the application and then create the project. A successfully created project in QSandbox allows the users to embed that project on their own websites or Research Hub or applications like Research Hub. We will just take this URL and then go to Research Hub, where we will paste the URL that was provided by QSandbox and submit the form. The submitted application is then shown on the home page. The last step of the pipeline is to just execute the project. People could go on the View Project link on the home page, and there they could click on the Q link button, which redirects them to QSandbox again, but this time the project is already available and is in an executable format. After discussing how Research Hub connects with QSandbox and allows its users to execute their research projects, we will now discuss a little bit about cloud orchestration on QSandbox. Today, we know that there are a number of cloud vendors in the market, for example, Amazon, Google Cloud, and there's some amazing open source cloud available like Massachusetts Open Cloud. Any user of our application may have a preference of using one cloud over the other. Therefore, we believe that it is absolutely essential that we extend the availability of QSandbox from just Amazon Cloud Services and supports a few other cloud services. In this project, we were basically focusing on two additional cloud services, which are Google Cloud and Mass Open Cloud. The next few sections will elaborate of how we automated the script of orchestrating Google Cloud and Massachusetts Open Cloud through the use of shell scripts and Python libraries. Thank you.
Now let's see how we can automate the process of running containerized applications on Google Cloud. Before getting started on the automation process, let's see how to install Google SDK and set the default credentials. The first step is to download Google SDK based on your operating system. Then run the install script and set the path. Now that we have the Google CLI set up, we will set the default credentials using application default login command, which will store the credentials to a JSON file in default location. Now we will point the variable to the file. Next step would be getting the user inputs. Below the input parameters required to run the Python script. Instance name, Docker image link, project name, zone, and then the storage bucket name. So below is the command to execute the Python script. Let's paste the command on the terminal. Before executing the script, let's see the current number of instances on the cloud, which is 2. Now let's execute the script. It will start creating the instance and list the current number of instances. Now we can see there are 3 instances. Let's go to the Cloud Web Interface and refresh. We can see py docker, a new instance created. If we go into the instance, We can see different details starting with the script, which is a startup script, and when you go to its serial port 1, we can see the current status of the virtual machine, which is currently pulling the image from the Docker hub and executing there. As the Docker image is now running, we'll see some more details on project creation and firewall creation. Project name, which is one of the parameters of the script, can also be an existing project. Also, as we cannot access directly the projects inside the container, below firewall rule will expose the project link outside the container, which will enable us to access the project outside the container. Now let's see execution plan and different aspects of Python script. Below are the sequence of steps. The first step would be creating a virtual machine. Once it is done, a startup script will be executing in which a Docker and Git will be installed and the Docker image will be pulled and executed. A quick walkthrough of the script. Below are the different functions of the Python script. So the most important one is create instance, which will be creating a virtual machine. So then we have delete instance, stop, and start the instance. So the main function has will be calling all the functions in a sequence, and these are the different parameters which are used in the script. So this is the shell script in which you have different steps of installing Git and the Docker and then running the Docker image. Now let's go to virtual machine and check the status. Here we can see the URL at the end of the execution. So the next step would be to access the project. So to launch the project, we'll be taking the URL at the end of the execution and using the IP address of the virtual machine instead of the local host to access the project outside the container. So the next step would be to get the IP address and access the URL. So here we can see that we are able to access the project, and let's check one of the Python notebook. So yeah, we can see that we are able to access the project. The last step would be to stop or pause the virtual machine. Once the user completes his execution, he can either delete or stop the virtual machine. In this case, we are deleting it. So once you press enter, we can see a message saying that the instance is being deleted. So it will take a while to delete, and it will display a message done. Yeah. So we can check it in the web interface as well. When we refresh it, there will be no instance. As a conclusion, we have automated the process to run containerized applications on Google Cloud using Python, but it has to be the Sandbox frontend that collects the data from end user and sends those input as parameters to Python script. Currently, the Sandbox team is working to integrate the frontend to call the Python script.
Now that you have seen on how to deploy a Docker image on Google Cloud Platform, we will cover on how to do that same procedure on MLC platform. So before we start, we will need few pieces of information to deploy the image. The first thing is the login credentials for the MOC OpenShift platform. This can be easily obtained by going into the MOC platform and pressing the button copy login command, as we just did here. The next piece of information that we require is the name of the project and name of the application. For our use case, we are using Research Hub MOC and Glyph Visualizer for the application name. The third and the final piece of information we require is the name of the Docker image along with the user ID. As mentioned earlier, we already have created our own specific Docker image with the code inside it, which is available at Hamel-Shan96 and Glyph Visualization Analysis. After we have all this information, we are just set to run the automated script. To execute the script, we can go to the command line and execute this command. The different types of argument that this script takes are as follows. The first, the login command. Next, the name of the Docker image, the name of the application, and name of the project. One more thing is we require is the directory in which the OpenShift client is present. More information on the different types of arguments and what they do is available on the documentation on GitHub. Now that we have all the required information, we can simply go to the terminal and execute the script. Once the execution of the script has started, the following steps will take place. First, the script will automatically sign in into the MOC platform using the provided credentials. The next step would be to create the project with the specified command line argument, that is research-moc. If we go and see on the MOC platform, the research-moc project is created. The next step will take place is creation of the new application with the provided Docker image. If we go here and see, then we have the Glyph visualizer started with the Docker image. The next step is to expose the application to the outside world. If we go to the website again and check here, the URL is already formed, and the script will also fetch that URL from OpenShift and print it out to the terminal. So we can simply go to the terminal and look for the script, which is as shown here. You may ask, what if we just have the Docker file instead of the Docker image? In this scenario, the script will first build for Docker image using the Docker file. Once the build is complete, OpenShift will push the Docker image to its local registry with the provided name. The script will now use this Docker image from the local registry and repeat the task of exposing it out to the container. We also need to note that as building Docker image from Docker file is a time-consuming task, it will take much longer than the normal deployment process. The entire script is written in Bash. There is also another script available to pull the latest version of OpenShift client. We will have a quick look at the Bash script here. More information about the script and the documentation can be found on our GitHub repository, Sharing Research through Data Science Environment on GitHub. Now we will go and check whether the Jupyter notebooks with the required environments is available on the specified URL or not. In the meantime, I would like to iterate over the advantages and disadvantages of OpenShift in comparison to AWS and GCP. The advantage is that with OpenShift, we only have to focus on orchestrating the deployment of Docker images on cloud and not focus on creation of VM instances. The disadvantages with OpenShift are that OpenShift highly regulates the security constraints on Docker images, and hence not all Docker images are successfully deployed on MOC. Our report discusses this problem in detail and how to best address this problem.
While in Google Cloud, we are almost ready to integrate with Sandbox. As we speak, our team is already collaborating with Sandbox team to integrate Google Cloud. However, with MOC, we are still having a few issues before it could be in a stage where we could start integrating with Sandbox. All the issues have been mentioned in our GitHub final report. Now we will discuss the next few steps about the project. Currently, we're using a Dockerfile image to orchestrate containers on cloud. However, the process of creating a Dockerfile can also be difficult for many users. Therefore, there is a need to create these containers through use of minimum GitHub code. There are solutions which already do so, but we believe there is a need for a more stable automation of this process. The Research Hub UI needs some more standardization. The current UI was developed as a proof of concept and it cannot be put in a production mode. Finally, there is a need for a more high-level pipeline for developers to add new cloud services in Sandbox. We believe the current integration is very manual and requires changing the main code base. With that, we would like to conclude our video presentation. In this video, we presented an application called Research Hub. Research Hub facilitates the task of sharing reproducible code. Research Hub is just one use case of such an application. We can see this application being used in a wide variety of scenarios, for example, by developers, instructors, in coding challenges, and many other places. For more details, please visit our GitHub page. And thank you for being patient listeners. Hope you have a great day.